Kia ora koutou, tēnā koutou, haere mai. Thank you so much for coming to really the inaugural Ngā Ara Whetū Salon. For those of you who aren't aware, Ngā Ara Whetū is a transdisciplinary research center. We just launched in February, and this is, as I said, our first salon where we are bringing together researchers of different disciplines to talk about one of these wicked problems that is really upon us right now, to talk about kind of the source of the problem, how bad the problem is, the scope of it, and then what we might be able to do about it. And so I'll introduce you to the panelists first, but I guess I should first, even before that, introduce you to the illustrious Jacqueline Beggs, who is my co-conspirator. We are the co-executive directors of Ngā Ara Whetū, and I have learned so much from that woman, and I am so honored to get to work with you, Jacqueline Beggs. Thank you. So this panel, I guess, would be a perfect example of kind of the types of teams we want to start pulling together. We've got representation from chemistry, from marine science, from biology, from oncology, and sociology. And all of them study some facet of this issue, and when you bring it all together, you get more of a holistic assessment and a holistic answer for where we go moving forward. Let me then hand it over to Dr. George Laking, the director of Te Aka.
Kia ora tātou. My name's George Laking. Yes, I'm a medical oncologist, one of the directors of Te Aka Mātauranga Matepukupuku, the Centre for Cancer Research. And so very glad to have just been asked to open our session with a karakia mihi, and we'll close the game with a karakia at the end. Whakatakatau ki te uru, whakatakatau ki te tonga kia ma kinakina ki o kia ma taratara ki tai. E hi aki ana te atukura, he tio, he hoka, he huhu, ti hei mauri o rā. Tuatahi mihi atua ki te ronga rawa, nāne hanga nāne tango, mihi ki te whenua nei, ngā moana, ngā maunga tūpuna, tēnā koto. Ki te mana whenua te rohe nei kia ngā te whātua tēnā koto. Kia koto, kua hui mai nei, I rungi tēnā kaupapa o te kiriho, no mahare mai ki tō tata hui. Tika hoki, te kupu mamahara I tātou mate, moi, haere oki mai rā. Honga mate ki te honga mate, te honga ora ki te honga ora. Kia ora tātou rā. Ka tuku mihi kia koto tēnei uri a te whakatohia, kia ora rā. So I'm a medical oncologist, but I also work at the hospital and at the university, and a lot of my work also has related to environmental health. So I'm involved with an organisation called Auditail, the New Zealand Climate and Health Council, and so it's been a forum for a lot of thinking about these interconnections. And I salute the work of Te Aka Whetū in bringing together multiple disciplines. Okay, I'll hand it over.
So let me just introduce everybody just once, and then let's just go right into questions. So let's start with Joel Rindelaub from chemistry, senior lecturer in chemistry, studies the microplastics in the air. Sam is next, right? Sam, I'm going to mispronounce your name. So I'm going to try it, and you can tell me if I'm wrong, right? Sam Ladewig. Whoa, good first shot. So Sam and I worked together on a couple of projects, and she's in marine science. She's a marine ecologist and studies microplastics in the ocean and their effects, and as well as how they connect to the rest of these things. Manuel Vallee, my long-term colleague and friend, one of my first friends here at the University of Auckland. He's in sociology, and he does sociology of medicine and sociology of the environment, and he's going to help us understand how we got into this mess with the plastics. And Associate Professor Anne Gasket from biology, amazing research around animals and all the different ways that animals interact with the environment and how they see and how they react to color, and then, of course, how plastic affects them as well. So I do want to start with the air. Joel.
Okay, that's fair.
Yeah, I thought so, since we do like breathing usually.
Yeah, it's overall, I rate it.
Yeah. How would you tell us the scope of the problem of microplastics in the air? I read one of your pieces and it sounded scary. Is it scary?
Well, we breathe a lot of things in, but yes, plastics are one of them. In fact, you are probably breathing them in right now. So it's not just outside, but inside as well, whether it's derived from things like clothing, carpeting, upholstery, whatever's around. Anytime you're creating that abrasion indoors, some of it's going to go into the air. Eventually, you're probably going to breathe it. So the question, of course, is is this bad for us? So I'll let some other people that maybe...
Yeah. So one of the
dictate
things
that.
you did was actually measure how much it is every year in the air, and it was like in the metric tons that I could not even comprehend.
So,
Can you help
yeah.
us comprehend how bad it is?
So one of our studies was looking at just the microplastics in the air in Auckland specifically. And what we found is that when you had waves crashing on the shore, it could actually be shooting with that sea spray microplastics into the air in these coastal areas. And we found in Auckland that the equivalent of 3 million plastic bottles falls from the sky every year.
And that's what's in the air that we're breathing.
That's in the air, yeah.
The smallest sizes you said are the most toxic?
Yeah, the smaller you get, the more it can travel throughout your body. And yeah, it's tough because what we find is the smaller the sizes you look, the more and more particles there actually are. So it becomes a bit of an analytical challenge as well.
Is it comparable to other places in the world, or are we just like uniquely bad?
That's the other thing, is that in some of our work, we've actually tried to go to the most remote places possible, like off the Southern Ocean. You think, oh, it's far from an urban area that should have less plastic, but we actually found more. The ocean, the marine environment, could be a reservoir for, well, plastic, really.
Sam, let's turn to you. What is the problem in the oceans, and what is the connection to other aspects of marine ecology?
The big problems in the ocean, I would say, is that it affects the functionality of the ocean. From all the little tiny creatures, bacteria, algae, right up through the largest ones that you know, whales, sharks, you name it. We've seen plastics in nearly all of them. And collectively, if we look at this as an ecosystem, it starts to change the way that carbon, oxygen, nitrogen, really important elements to us in our existence. It changes the way that they move through the ecosystem, and that changes the way that things function, and it's important to us that we get these elements in the right format and things. So that's the scary aspect of it, I think. Not just that they're in the animals, but it creates this holistic problem that everyone's impacted by it.
And do you have a sense of how, is it like as bad as like the 3 million bottles falling from the sky amount of plastic that Joel was saying in terms of what we're dealing with in the ocean?
That's a great question. A lot of people have tried to quantify this in multiple ways. So you can see a range of models that output different expectations for how much is in the ocean, but I think what ends up is that they end up in the ocean. That's where they land, specifically in marine sediments, and these are really important functional spaces that support our biogeochemical cycles on Earth.
I think I saw in one of your pieces that this also then, of course, affects the entire like food chains as well, because then that's part of why everybody has plastics in them.
Yes, for the pod.
Well, what about the animals, Anne Gasket? Can you talk to us about what's going on with the animals that you study?
Kia ora. We're interested in which types of animals are eating plastic and why as well. And when it comes to which animals, we've started with the seabirds, because this region that we're in, Northern Aotearoa, is the most important place in the world for seabirds. And it may not be necessarily what leaps to your mind as what is special about our city, Tamaki Makaurau, but we are custodians for more of the world's seabirds than anywhere else. And we're doing that right here in this big city, which has a lot of bright lights, a lot of shipping movement, and a lot of plastic going into the ocean. So we started with the seabirds, and it's surprising how little. I mean, I thought there'd be some sort of database that said, yes, these are the birds that we found plastic in and these not. Doesn't seem to quite exist yet, so we're starting with it. So birds that are found dead on the beaches by community volunteers, birds that are sent to us by iwi in Northland, birds that end up in the museum, or birds that end up at like the welfare bird care centres when those birds have been taken to them sick or injured but they haven't survived to be released. We're checking to see what plastics they've been eating. And so some birds are eating a lot of plastic, and they tend to be ones that feed in ways that kind of encounter plastic. So maybe they're just nibbling across the surface, or maybe they're eating a lot of animals that are buried in the sediment, like Sam said, where there's a lot of plastics around. But then other birds are quite low in plastics, birds like gannets that do plunge diving, and they're kind of looking at the food they want to eat from a height, and they're identifying their food and diving down to it. But I study a lot of things to do with the smells and colours that are in the environment, to do with like fruits and flowers, why are they those colours, and what animals are they talking to. But then when we add artificial smells and colours to the environment with our plastics, then the animals are encountering them and experiencing those smells and colours of plastic in ways that are different to how we do. So that's what we're trying to find out, how those animals are seeing plastics, how they're smelling the plastics, and how that affects which animals are more vulnerable.
Do you have a sense of like what the scale of it is in terms of the animals you've been looking at?
No, I mean, we're still on a very case-by-case basis, and we're probably looking at 1,000 birds so far. And some of those we get quite a lot of, and some of them not so many. So it's a very ad hoc kind of patchy process, because obviously we don't want to cause any damage to taonga species. But if an animal has died and people are happy for us to have a look inside, we'll have a look.
So you'll never know if it's a representative sample, but it gives you at least an idea.
I mean, certainly, for birds, they end up with plastics and they get entangled in it. Maybe they are incorporating into their nests and things like that. If they ingest it, it can block their stomach and prevent them from eating real food and getting nutrients from it. But it also can infiltrate their tissues, plasticosis as well, and affect. That's kind of a newer emerging area of study. I mean, some birds are surprisingly unaffected. We found very little in a whole lot of albatross, which is a really great result. It's one of those, a student project where they find nothing, but it's a wonderful result because those albatross seem to be eating less plastic than we might have expected.
George Laking, you're up.
Kia ora. So it permeates everything: air, water, our animal, fauna, probably flora as well, I dare say. And human beings. From my reading, we probably all ingest at least 100 microplastic particles a day, and we probably inhale maybe twice as many as that in every day. The number apparently is about 1,000 times higher for infants that drink from plastic bottles, on one report at least. So we're certainly internalising this stuff. At this point, I've got to give a bit of an apology because a lot of what we're all internalising has been generated in the name of health. I'm in an industry that generates a heck of a lot of plastic waste. Believe me, it is on our minds, and can refer to the work of the Sustainable Health Network in New Zealand, trying to cut down on this stuff. So ingesting those microplastics, I feel that we quite embarrassingly are at the threshold only still of understanding the health effects thereof. And I think that old saying holds true, out of sight, out of mind, what you don't know can't hurt you. And I think it's something that we just begin to take the lid off. There is certainly quite a few reasons to be suspicious. I suppose you could flip that round and say we don't clearly have an epidemic of cancer attributable to microplastics in the same way we do have epidemics of cancer attributable to smoking tobacco or ultraviolet light exposure, etc., those other environmental causes of cancer. We have seen changes in the profile of different cancers in the population during this era in which plastic has become so prevalent in the environment, i.e. since about 1960. And some of our colleagues in Christchurch did some good work putting this together and into a paper which I found quite influential for my own thinking. So, for example, with colorectal cancer, still fortunately rare, but the incidence in younger people of bowel cancer is increasing. Is this something that could be explained by exposure to microplastics? At the same time, there's been quite a few things about our environment that have changed in tandem with the tsunami of plastic. I'm real glad those 30 million bottles don't fall all at once. I had this image of a sort of giant Monty Python sort of, but But nonetheless, they fall and we have to breathe them in. So bowel cancer accelerating in younger people, and there's certainly some decent hypotheses as to how microplastics could be instrumental in the onset of different cancers, both in terms of direct genotoxicity and also in terms of the more indirect mechanisms of carcinogenesis, such as hormonal effects. I'll probably pause just now. I could talk a bit more about those things, but that's where we're at.
That's fantastic for knowledge for us. I want to turn to Manuel Vallee. Manuel's a sociologist of medicine and of the environment. I mean, can you give us a sense of how we got into this wicked problem?
That would take more than 5 minutes, but there's a lot of factors. I mean, there's, as George pointed out, there's a lot of products that are used in the medical field that are very useful and that help save lives. And there's products, plastic products that we've come to use because of their incredible convenience. And I mean, to get an overview, you'd have to kind of look at each of these uses and get a sense of, well, where do they originate? For me, as a sociologist, I tend to look at corporate behavior. How do they compel us to use their products? And that's kind of where I start. And I think that in order to have corporations actually behave in a better way, we have to incentivize behavior. And if you have policy that doesn't penalize corporations for the production of toxic waste or things that are toxic, and if you don't penalize them for false information that they put out, if you don't penalize them for lobbying our politicians into creating the policies that allow them to do, I mean, all these things have to be addressed in order to curb the corporate behavior. So for me, that's part of the problem. The other part of the problem is an apathetic political culture. If we're going to be able to, we can't rely on the politicians to do this. Jean-Jacques Rousseau, who is one of the biggest advocates for democracy, was very clear on the point that representative democracy would not work because invariably, not occasionally, not sometimes, invariably, those who are elected to represent our interests will take care of their interests first. And for him, he was a big advocate of participatory democracy. And he was from Switzerland, and they have a pretty robust system of debating things. And there's countries divided up into canton districts where they get together on a monthly basis to debate issues about what kind of world they want to create, not just in the next 3 months or 6 months. They've got 5, 25, 50, 100-year plans. And they look at the vision as to where they want to be in 100 years, and then set policies in accordance with where they want to go. And I think that's a principle of backmapping, which I think is something that we need to start looking at. And I'm starting to talk about solutions, so I'll stop there.
No, that's great. That's a perfect lead into, like, how do we mitigate this problem? Why don't we just go straight down the line? Sam Ladewig, what do you think is the most important thing we can do to mitigate this problem?
I'm just going to start by saying we need plastic. This is the world that we're in. We need it in the medical industry, don't we? Yeah, and we need it in our life. We need it in our clothes. Half of us would be probably naked right now without it. But we don't need all of it, right? Think about your household, the items that you have there, your workplace that you go to, your favorite restaurant, bar, your child's daycare. We don't need all of that. We're living in luxury. We are totally abusing a system that we've created. And I think we need to look back on ourselves and reassess because we don't need it all. And we're coming up with great solutions, right? Bioplastics, maybe, reusable things where we just don't throw away stuff, creating a culture where throwing away is just not what's going to happen anymore. I think we're talking about it, so it's a good move forward.
And the throwing away, of course, allows the leaching into the groundwater, which, of course, goes into the terrestrial land and then, of course, connects to the ocean, et cetera, et cetera, et cetera, all of our water bodies. So, yeah.
Yep.
Joel, what do you think? What's the most important thing we can do to
Well, if you don't want plastics in your lungs, there's actually a pretty easy solution.
Don't breathe?
Just stop breathing. And turns out that was really good to lower your carbon footprint in the long term as well. So that's
That's the first.
That's the first step.
Okay,
yeah.
so then if we, like needing plastic in medical use, if that one's a hard one to achieve, what if we just held our breath for 10 seconds longer?
But yeah, I mean, seriously, we basically need to reduce the amount of plastic we're producing. We're currently on an exponential increase just in capabilities. So recently, there's been as much as like $180 billion invested in plastic production infrastructure. So that means...
That's here.
That's worldwide.
That's worldwide.
Yeah. So that means the people that are producing plastic are not planning on stopping anytime soon. We just need less plastic around that is non-essential for things like medical or other uses.
George Laking.
Kia ora. Just wanted to mention, I suppose you could burn it, but that's...
Please don't.
Yeah.
No.
Yeah, just in case anyone walks away thinking, we could just burn it. Also from the cancer point of view, leads to dioxins, and those are very well established carcinogens. Actually, the term popped into my head. They talk about cyborgs, which most of us probably aren't, but we're probably all plastorgs by now. In the sense of having plastic inextricably incorporated into our organism status, which makes us different from anyone before 1960 or before the 20th century anyhow. In the health domain, I think it's got to make anyone feel uncomfortable realising that we're sharing our bodies with inhabitants that we don't have a good understanding of their size, their distribution, their quantities. It's like a whole untapped realm of human biology that we're right at the threshold of. And so it leads me to start thinking, how could we take the lid off some of this? One of the things that we often do with environmental exposures is try to understand the distribution through the body in human tissues. So I've been quite interested in radiation exposure, and there's a vast amount of work that looks at the distribution of radionuclides, for example, in human tissues. So something analogous, very desirable, I think, for understanding the intersection of plastics with human biology. You can do some of that with radio-labelled studies. There's some people have labelled PVC with radioiodine, which we can image. All that kind of stuff is heck of an interesting from my perspective. While I'm doing this, what I'm really waiting for is the point at which a overload of micro and nanoplastic in our bodies combines with an overload of various other stresses on the body, and then we maybe do start to see the epidemiology take off. I do still feel at this point it's fortunately at a relatively low level, but you start down a pathway of exponential growth. Who's to say where you're going to wind up, people?
Anne Gasket.
Do you want to know the most common items we find inside animals?
Yeah, sure.
Party balloons and plastic bottle tops. So if people could stop having parties, I think that would be great.
Or at least don't use the balloons.
Yeah, the balloons, water balloons, party balloons, they're really common. We've had, even the biodegradable balloons, we've had them in the harbour in some mesh bags, and after 12 months, they still looked pretty good. So if I could encourage people not to use those things and to pick up rubbish. I mean, it's an old school thing to do, but there's a lot of rubbish on our streets, and it goes down the drains and straight into the gullets of our beautiful animals out there in the harbour, the animals that we're the custodians for, that travel all around the world. So genuinely pick up some rubbish, and you're genuinely having a positive and immediate and functional effect on the animals and their ingestion.
Manuel Vallee, you started this. You get the last word on this, and then we're going to open it up to questions.
I've got a couple thoughts. One is we often hear the 3 R's, they reduce, reuse, and recycle. And I'd add 2 more R's. One is refuse, rethink the system, as well as reduce, reuse, recycle. The other thing we need to do is, I think, focus on the low-lying fruit. There is a lot of low-lying fruit. There's some things like the medical applications. It's going to be really difficult to wean ourselves off of those, but there's plastic bags, single-use plastic bags, single-use plastic bottles. Those are things that are in the easier to address basket. And there's some places around the world that have made a lot of progress. I mean, we've finally made some progress on the plastic bags, which is good. And then, coming back to this idea of citizenship, we need what Michael Carolyn would call democratic regulatory politics that starts at the level of consumption. So instead of just having, maybe citizen oversight over the regulation of products that are already on the market, we need citizen participation in what gets actually produced. There's been a deferral of authority to executives as to what kinds of products we need. And they're not in it to make products to help people at the end of the line in a capitalist political economy. Let's get real, people. It's about profits. It's what will maximize profits. So we need to find an alternative system where citizens have a lot more say in what kinds of products are being made. And part of the calculus needs to include not just is it profitable, but how will it impact human health, community health, and ecosystem health? That needs to be part of the conversation.
I'd like to get some questions from you guys. Who has a question for? I mean, it could be chemistry, it could be marine ecology, it could be oncology, sociology, or biology.
Hi, I'm Stephanie Dawes. I'm from the Structural Biology Group. I was just wondering, it's all very encompassing to talk about plastics, but there are different kinds of plastics. And I was just wondering if you had some thoughts about which kinds of plastics are maybe the worst, and where we should start, because banning all plastics is going to be tricky, but maybe there's some low-hanging fruit that we can target.
Does the chemist know?
So that's a very, very good question, because there are different types of plastics, different types of polymers, but importantly, different plastic formulations. Different types of plastic are going to have different functions. So to give you an example, let's say your food container that's plastic that you're using, that's hard and brittle, but yet you could have an IV bag that's made out of the same polymer, but that's soft and pliable, because it has different small chemical additives to them. And so when we think about from a lot of things that have to do with endocrine disrupting diseases and things like that, it's these small additives into the plastic formulation which are really of interest from a toxicological perspective. When we come up with new ideas of replacement plastics, those are the things that we need to be concerned about. So Sam mentioned bioplastics earlier, but what if they're just using the same chemical additives? And of course, the bioplastics, where is that coming from? Is there land use change associated with wherever that is coming from? So there's a lot of questions, and it's not necessarily a straightforward answer.
And I know, Sam, you're working on car tires as well, because that's another thing. I imagine that this kind of wearing down is also, and it's another kind of plastic. How much does that matter?
Yeah, so today, vehicle tire particles are thought to be the number one micro or nanoplastic in the environment. We don't actually know that, and we're just sort of hypothesizing, we being the scientific community, because we're establishing the methods to do it. We currently function on something that can only tell us part of it. This particle may be rubber, but it doesn't tell us if it's rubber specifically from a tire. So anyway, there's the thought that we have a lot of tire particles out in the environment, and the numbers are really high in terms of other types of plastic out there. So it's one to be thinking about for sure. What we do about it, I don't yet know.
Well, it would hint at more mass transportation and less car transportation, because that's fewer cars on the street using those tires.
That's right. And what we're seeing in this world today is going towards maybe heavier vehicles. We're moving towards EVs, right, to get away from exhaust pollution. But there's this also other side of it, non-exhaust pollution, being tire wear and brake wear even too, that we need to be thinking about. It's not really clear in the literature if these EVs are emitting more particles because they're heavy, so it depends on a lot of things. They also do regenerative braking. They have special tires, so this may mean that these tires don't wear as much even though the vehicle is heavier. It depends on a lot of factors, and it's a really new research field to just keep your eye on.
All right, let's take some more questions.
Hi, Sean Lott from SBS here. It's clearly self-evident, I think, to us all that ingesting a large volume of microplastics sounds scary. I think it seems self-evident. The thing that I think I've struggled with in looking at the literature is, and I think you hinted at it, the multifactorial problem we have in that everyone has been exposed to microplastic pollution in the same time frame as many other pollutants and many other societal and environmental changes. And so I guess my question is, how do we go about extracting the actual damage? How do we isolate that? Because I think unless you've got a real smoking gun, right, it's always going to be really hard to convince anyone that this is a genuine problem rather than a potential problem. And I've struggled. I mean, totally on board with everything you've said about the self-evident nature of this, but I do struggle to see, what's the hard link that we can draw? Because I think without that, it's hard to really get anyone's attention.
Do you want money?
I want money.
Because the link that we're trying to make now is people won't care until we talk about in terms of money. When we can monetize this, that gets businesses' views, that gets industries' attention.
I understand what you're saying, and I think you're quite right that considerations of, precautionary principle considerations are not going to happen unless there's financial drivers. And I think one of the issues around increased plastic production is it's cheap. It's so cheap to make, and the more we move away from oil as an energy source, well, what are we going to do with it, right? So what I'm meaning is, how are we going to derive and I'm thinking around health impacts primarily, what's the experiment we can do? There seems to me a gap in the self-evident, scary nature.
So you're looking for something to link the plastic consumption to health detriment.
Correct. And how do we separate that?
Is there?
Because I think without that smoking gun, it's easily dismissed as the usual hand-wringing from the usual suspects. The environmentalists are always going to tell you something is bad for you and you should stop, blah blah. But and I think it's hard to actually get the attention of politically or financially the people that you need the attention of to actually be able to achieve some change. Yeah, do you know what I'm saying?
Yeah, I can have a go. I'd really like sociology friends to fix up the current problem with getting anything that anyone says from science to be believed when it goes against some powerful interest. But assuming that we do have some sort of rationality still remaining at some level, what we're really looking for is strong scientific inference to understand the interaction between exposure to micro and nanoplastics and health. And I feel incredibly chauvinistic coming from human health direction, but of course it's so much more than that. It's the encompassing environmental health, but human health is the part of that I work in. So, and in the smoking gun concept, well, I think there's a little wisp of a curl of smoke, but we want to have a big kind of Napoleonic cannon amount of smoke to say that's it. So just a couple of thoughts. This is approach it from two directions. So we've got the community population level direction, and then we've got the cellular biology direction. At the population level, our epidemiologists, I'm sure, can do all sorts of sophisticated things relating to distribution of exposure. Because if you think about the other things that have happened since the 1960s, people have been quite unequally exposed to those things. From a scientific perspective, it looks like microplastics and nanoplastics have got like the advantage of being nearly ubiquitous. So it's pretty constant exposure, and I think that sort of thing can help epidemiologists to tease out that there's something more ubiquitous going on than maybe those other things, because a competing hypothesis would relate to the post-war Green Revolution and the increase in calorie load in our diets over that time. So the whole sugar, fat, that's got its own hormonal implications for cancer, but that's been quite unevenly distributed around global populations. At the cellular level, we need our biologists to go looking for these things inside cells, tissues, and better draw out the pathways by which they might lead to the diseases we see at a population level. We're right at the threshold of it. We seriously are, but there's a whole lot of interesting stuff about interactions between microplastics and colonic mucus and how that might affect accessibility of particular microorganisms to the cells that line the colon. And we know that small particles become internalized inside cells, and we know they carry a whole lot of things with them, including some of the I think they're called plasticizers, the additive chemicals you mentioned. A lot of those are aromatics. Body generally doesn't like aromatics for cancer reasons. The bisphenols, that's the hormonal cancer one. So we can see those going inside people's bodies, but yeah, there's a hell of a lot more to be learned, that's for sure.
On the way to you, I'll just say it's incredibly clear from studies of the tissues of animals that have plasticosis or microparticles of plastics embedded through their organs, that those organs are inflamed and no longer functioning.
On the question of smoking guns, I think one of the things we need to understand is how industry, starting with the tobacco industry at least, has become experts at weaponizing uncertainty. In science, there's always uncertainty. You're never going to get 100% on anything. But the tobacco and chemical industries have been able to fixate on the uncertainty and weaponize it to have it so that people think that it's not conclusive yet, and then that impacts policy. So I think we need to fix our ideas about what it is that we need in order to be persuaded that there's a problem. Because if we're looking for the smoking gun, then we're playing into industry's hand completely.
Just to Sam's question about the money thing too, it's like, to value money over and above ecosystems and planetary health is something that falls within that sort of sociological and political realm. But what drives behavior? Should it really be all about money? Yeah. That's, I think, the system change that Manuel's talking about. Anything else on that, or should we go to a question?
Hi, Timothy Yang, SBS, one of Anne's master students. I just had a question. I heard an anecdote when talking to somebody recently about the coming in of plastics. It was this in vogue new thing that everyone wanted, like bread used to come in wax paper bags, but then they came in plastics, and you were the cool kid in school if you had your sandwiches in a plastic bag. I'm just curious if you all have seen kind of in your lifetime or in your professional fields that shift away from, oh no, plastics isn't the thing that we should be using. The recent metal water bottles that are so popular, people are moving away from plastic water bottles. I'm just curious if you guys think that's the way to kind of move away from it. You make it the cool thing not to use plastics, and how we even push this type of thinking, or if that is the way we will truly move away from our overconsumption of plastic.
I mean, I think I've certainly seen capitalism push this idea of decrease your plastic use by purchasing a whole lot of new products and throwing out the plastic that you have.
So that it can leach into the water.
Yes, exactly. So, yeah, I mean, I'm a huge op shopper. I basically just rent things from the op shop and just return them there to resell to somebody else when my kids grow out of things. But yeah, I mean, I think that capitalism is very much on board with suggesting various new things should be fashionably purchased. So, yes, how do we do that in a way?
And buying things new and not, yeah.
Let's talk to the sociologist.
Look, we're not going to consume our way out of the problem. And every time we're told to buy something to solve the problem, it's distracting us from actually looking at the systems of power, the policy. That is where actually change needs to take place. So yeah, sure, we can stop using plastic in our lives. That's definitely a good thing, but it shouldn't come at the expense of being politically active and putting pressure on the politicians to do the right things. And I say putting political pressure, I don't mean as individuals. Yes, we can do it as individuals, but part of what we're missing is collective action. Part of what we're missing is building up communities where we have, we used to do this in California where I'd organize parties and the price of entry was everyone had to, I had postcards pre-printed that were targeted for particular politicians, and everyone had to write a letter to their assemblyman or to their state senator. That was the price of getting into my parties, and it was successful.
Such a Berkeley guy.
Yeah. So yeah, I guess along those lines, you said make it cool to not use plastic, right? But another thing what that's doing is it's putting the onus on the consumer, that it's your fault that we're in this issue with plastic waste, not the people producing it. So one example of a tactic that has been used is, hey, recycling, right? It's your fault we have plastic waste because you're not recycling. But guess what? It's actually not economically feasible. But don't take my word for it. Talk to the industry insiders who've actually been quoted saying that in the 70s. So that is, again, a tactic that is used to shift blame away from, I guess, producers. But of course, it's an issue that we all deal with, and we all have to work together to try to overcome it.
Why don't we take one last question?
Hi, I'm Ines from Institute of Marine Science. I've been wondering, in context of that collective effort, where is the critical mass? Thinking of New Zealand, how much of a portion of the population do we need to get a movement going, to get a momentum that is putting pressure on industries and the political agencies to change the way we're living or to change how the country is running?
So you want a social tipping point?
Sort of,
a political tipping point?
Yeah, because maybe for context, a few years ago in Sweden, there's been a lot of public shaming on people who take flights within the country. And this has taken such a big momentum that there have been changes on the political scale. So I've been wondering, where's that critical mass? How many people do we need?
Does anybody know the answer to that question?
Well, so I study animal behaviour, and people are animals in some ways. And something that really struck with me is often people say, oh, the people who really need to do the action or know about this aren't present in the room. But the things that are most likely to affect people's behaviour tend to be ideas that they've heard through existing relationships that they have that are already communication rich. So you can't jump a level. You can't immediately talk to people who are disconnected from the issue. I think perhaps networks and chains might be a better way to conceptualise it rather than specific numbers, because it's kind of propagating and sharing information through trusted existing compassionate and caring networks that actually does cause some change.
I mean, I was just going to put in a plug for the arts and humanities. I was quite convinced when I heard that STEM got us immunisation against COVID and social sciences got us a way to roll that out and distribute it, but to actually get people to take the darn thing, you had to be able to tell them a story that made sense to them, which I think we get from arts and humanities, which we need so desperately in the university. It seems to be harder and harder for people to understand that or appreciate that. I think it'll make our society a lot better, the better we are at telling those stories in those ways.
Yes, hello, my name is Karina Ahlqvist, so I'm an exchange student and I'm actually from Sweden. So we had this, it was called flygskam. So you are not supposed to fly, and that has actually changed now. So people are flying more than ever now. So that's very unfortunate, but it was a good point when that took place. But I was also wondering, when we have such a tremendous transdisciplinary panel here, is there any way to connect to the kind of political agenda or otherwise, how all this collective competence and knowledge is transferred where kind of more activities or actions can be taken in some sense?
So,
Because he's the sociologist on the panel.
yes,
I mean, I'm
the
the political
sociologist.
scientist, but I'm just a moderator today.
Look, on the previous question about the social numbers, I don't know that I don't know what the threshold is. One of the things that I have tried to do is try to educate as many people about environmental issues as possible so that they have some sort of eco-literacy when they leave the university. And I'm thinking about it. We play a lot of board games in my household, and a lot of strategic thinking is involved. And I tend to take the long view of things. And part of what we need to do is educate the next generation, giving them the tools to understand when ecosystems are in distress, knowing what to do about it politically. And this university has completely fallen on its face. Yes, we teach more ecology or environmental substance courses than we did 10, 20 years ago. But it's only going to speak to students who are doing majors or who have a natural inclination to those issues. And so we have 95% of the students graduated with no eco-literacy. And there are places in the world where they've actually instituted environmental awareness graduation requirements, where students have to take some course that touches on environmental issues so that they have some sort of basic understanding. And this speaks to Anne's point about the fact you can't have people jump from no action to action unless they understand the consequences, the issues. And I think we have a moral duty to provide the next generation with the tools that they need.
I just also want to add, I am not supposed to be a panelist, but this is part of my area, so I have to chime in. I think probably our biggest struggle right now, over and above everything else in terms of what we've all been talking about, is the disinformation in the media ecosystem. There is so much both mis and disinformation, both about these topics that are complex and hard to understand, and of course what Manuel was talking about the, using doubt as a means, because science has a lot of, uncertainty, but using that against itself. But also there's an anti-science, an anti-institution itself. The academy itself is under a lot of misinformation and disinformation. There's a new type of research that looks at kind of the inoculation of young people against misinformation. It's sort of pre-bunking so that they can spot this anti-science, anti-academy, anti-human values kinds of things. And I think that that's going to be really important to integrate into all these ecology programs.
As far as public communication goes, just like to make a quick plug here. If you would like to know my thoughts on misinformation and plastic pollution, come on down to the Q Theatre 7th through 11th of May at the New Zealand Comedy Fest for my show, Science is No Joke.
That's great. That's a perfect place to end. Neil has a question.
No, I think George's point about stories is really important, right? Because I think there's an analogy between micro and nanoplastics and social media posts, right? And you think of the billions of social media posts that are filling people's brains in the way microplastics are. And I think they're just as dangerous.
Sounds like a cartoon in this.
There is, yeah. It's a comic. It should be, but it's. But I think the point is here. What the university fails to do is provide us with the spaces. Because I'm from the arts faculty, right? I do now. Totally, I just do comics. And it fails to provide us with the spaces where we can get together so that you can talk to us about what's needed and we can talk to you about what's needed, right? So despite all the talk about transdisciplinarity, the university never puts money...
Don't say never, we just gave you money.
No, well, that's fine, yeah. I got some money from TIFF. But no, my point is they'll give you money for explicit outputs, right? They won't put money into supporting the space that's needed for us to talk to each other so that we can produce collective practice which allows us to address all of these issues in a joined up way, right? That's what we need to do. We all need to be speaking to each other and bringing our own set of skills to the table so that we can produce a concerted response to our problems. And what happens is we all end up aspiring to that, but because there aren't the resources to allow us to do it, we don't do it enough, and it's a failing on behalf of the university.
Well, Neil, help us to organize that. It's such a pleasure to get to meet you all and to hear all of your wisdom and the background on your research. I thank you so much for doing this with us.